Have you ever wondered that how can we hear music from a speaker or a friend from across a room? So in today's lesson, we'll study how the sound waves are produced, how sound waves travel as longitudinal waves, and differentiate between frequency and amplitudes, and then we'll explore how animal and human hearing ranges differ. And there's an interesting fact. Do you know that? The cats, they hear sounds up to 64,000 hertz. This is about 3 times higher than humans. So let us see how sound wave is produced. Sound is created when something vibrates, sending waves through the air or any other material. A vibrating object causes the surrounding molecules to also move. This disturbance travels through the medium until it reaches our ears. You can see in the figure in front of you. So there are some air particles which are concentrated in some parts, and in the other parts they are a little bit far away. What are the few examples of sound waves? Vibrations of the guitar rings. The vibration produced in the person's vocal cord are also an example of sound waves which are produced by the vibrating source. Hold on for a second. Just hum and feel the vibration in your throat. And then you can draw on a paper that how does the sound waves look like. Sound waves are waves which travel to different medium as longitudinal waves. What does it mean by longitudinal waves? The particles of the movement move back and forth parallel to the direction the wave is traveling. So this movement creates areas of compression where the particles are closer together, as you can see in the diagram in front of you, and the areas where the particles are a little bit far away. These are the rarefactions. Mostly scientists and musicians, they are using sound waves to produce a trace to help them analyze the sound. But remember, still, although this representation on the oscilloscope is that of a transverse wave, but still sound waves are longitudinal waves. About the characteristics of the sound waves, there are 2 key characteristics. Frequency, it is how fast the wave vibrates, and we say it's the number of cycles per second. It's measured in hertz. Amplitude is the height of the wave from the central line, and it tells us the loudness of the sound. What's the frequency and the pitch? When we say something has a higher pitch, we mean it has a higher frequency. What does it mean? We mean that there are more waves passing through a point per second, like a chirp of a bird. Lower pitch means fewer waves passing through a point per second, and it creates a lower pitched sound, like a drum beat. Larger amplitude makes the sound louder as the waves carry more energy, and smaller amplitudes results in softer sounds. There is a quick quiz. Take a paper out and tell me how you compare the two sounds in front of you. The A sound was having a constant pitch, as you can see in the trace in front of you, and it has a lower pitch than B. Why? Due to the lower frequency. The B one, it has a higher pitch and loudness because it has a higher frequency. And it also represents a louder sound at the beginning and at the end, but there's a softer sound in the middle. So there is an auditory range. What is the auditory range? It's the range of frequencies that a person or animal can hear. Remember, different species have different abilities to hear sounds. So humans can typically hear between frequency of 20 Hz to 20,000 Hz. As we age, the ability to hear high frequency often decreases. Elephants can hear from range of 6 to 12,000, whereas bats, they can hear from 2,000 to 110,000 Hz. That's a big range. Let's have a quick review. Take a pen and write it down. Do you think that the sound wave is produced by back and forth movement of particles in a medium? The lower the sound frequency, the lower the pitch. Human can hear sound frequencies ranging from 20 to 20,000 Hz. The first one is false, as this is not transverse wave, this is longitudinal waves. The second one, the lower sound frequency means the lower pitch. Definitely that's true. If the last one, human can hear sounds from 20 to 20,000 Hz, that's also true. If you still cannot answer these review questions, go back to the video and start again and learn the contents. So there's an assignment for you. Spend 20 minutes in the park, place in a comfortable place, and you just list the sounds that you hear. And please tell me whether they are high-pitched sound or low-pitched sounds.
For tutoring and resources, log on to www.physicsonlinetuition.com.